Okay, so this is where we left off the other day. We were talking about how you can use functions to do a menu. So again, the purpose of a function is to kind of split your code up. So instead of having everything in main, it kind of separates it into these separate modules, or what we call functions. And they only have one function, one job. And so the job might be to display a menu. And so all of the code to display a menu would be in this one function. And then that way you would just say display menu in the main. And then if you cared about changing the menu items, you would go to that particular function. But if you weren't concerned with that, you would just see one line of code in main say display menu, and you would just skip past that. It would only take up one line instead of like 10. Because again, if you have like 1,000 lines of code, it's overwhelming to try to section like what does this do and what does this do. And so that's what the purpose of the functions are. Also, reusability is good, but not really for menus. But if you are using the same menu, you can use it in other programs, or but we are going to do a menu program in just a bit. But I want to talk about a few more things before we do that. And so we kind of talked about this. So we did a lot of functions that were what we call void, means they don't return anything. So the purpose of those functions would be like to display a menu, to print something a screen. And so they're just a list of things you want to do, but they don't actually return any values. Okay. So you might think like, why would I ever want to return a value? Can't I just do everything in the function? And it's a good question, because like if you're calculating something, couldn't you just print it right from that function? You could, yes. But this is a hard concept to kind of get, but sometimes it's good to have the raw data, like to be sent back the answer, so that you can choose in the other function that you're calling it from, like probably from main, like right now. But you can choose how you want it to be printed. And so what I'm saying is like, maybe you're always using this function. Like, let's say there's this wonderful calculation that you're always using. So you write a function for it because you're going to reuse it over and over again. And sometimes you might want to display it with like 2 decimal places, and sometimes with 3, or you just want to format it differently. And so if you don't want to keep changing the function, because sometimes in your program you want 2 decimals and sometimes you want 3. If you format it and decide how to print it over there, then it always prints like that. Or another example would be, what if you wanted to take that value and put it into an equation? You didn't want the answer to print on the screen. There's no way once it prints on the screen for you to really take it, put it into equation, except manually looking at what the printout is and then go back to your code and manually putting in the answer. And that's not really efficient. And so sometimes we just want the raw data, because then we get to decide. And so the raw data means like not formatted. It's not being printed. It's just handing you back the answer from the calculation. Then you get to decide, how do you want to format it? What do you want to do with it? Maybe you want to put it in another method, or you want to put it in an equation, or you want to do something else with it. And so you get to decide, because sometimes you might want to do one thing with it, and another time you want to do something else with it. And so that's the purpose. A lot of times when we do calculations, we return the answer instead of printing the answer. Okay. And so a lot of our return functions will be calculations. Okay. And everything doesn't have to be called from main, but it's just because we're just starting off, main is automatically called, so we call everything from main. But one function could call another function, and it could call another function. You could keep going. It's just a way to get from one place to another. And it always comes back to where it was called from. And then when it's done with that, it'll come back to where it was called from. And so you can have like A go to B, and then B go to C. And then when it's done, the C will come back to B, and then B will go back. So eventually you'll get back. Okay, so we are going to take a look at this program. And so this one, we have, I wanted to talk about, actually, this is just a return statement, not a return function, but we're going to talk about a return function in just a bit, but it's good to know all of that. But the return statement is always used in a return function. You need to have it, but a return statement can sometimes also be put in a void function. Okay, so you don't need to have it because it's void, so it's not supposed to be returning anything. So you might say, well, why would you have a return in a function that doesn't return, right? And so here's an example of a void function. See, so this is the prototype because the function comes after main. You need to do this. If you put it before, you would not. Here's the function here. And so it's a divide function. It takes in 2 numbers, so arg1 and arg2. They're both decimal numbers, so they're both doubles. And then if the arg2 is 0, because we know that we can't divide by 0, so if it equals 0, then we're going to say, sorry, I cannot divide by 0. Now, we have a return there. The return actually sends it back because what happens is if you don't return it back, then it will print the quotient. Okay. Now you could probably just put an else in here also, so it doesn't, so it doesn't do that part. And then it wouldn't do that part and it would return anyways, because when it hits the end of the function, it returns anyways. But if you wanted to skip a particular line, like in this function, in this example, you would put return and it wouldn't go to the next thing in your function. It would return back to where it was called from. But again, you could just write this differently if you didn't want to use the return. But sometimes there's good reasons where you have some sort of condition and you want to send it back. You don't want to continue with it. And this is just an example of using it a different way instead of doing like an else. Does that make sense to everybody? So it's not returning a value. It's just returning back to where it was called from. So when you're using it in a void function, you don't return a value because if it's void, it can't return a value. But you can put return if you want to send it back at a particular time before it's supposed to get sent back. Okay, and if you go back here, all that it's going to do is ask you for two numbers. It takes in the two numbers here on one line, saves one in number one and the other in number two. It's going to pass those two numbers in when it calls the divide function. And so the number one's going to go into arg1 and number two is going to go into arg2. And then if arg2 happens to be 0, it's going to say, sorry, I cannot divide by 0 and return. And so if you had like 12 and 0, for example, it'll say this and it'll go back. It won't print this because the return causes it to go back here. And then that's the end of your program. Now, if you didn't have zeros or second number, then what would happen is it wouldn't match this if statement. And the if has the curly braces, so it includes both these lines because you have to be careful of that it includes the return. And if it doesn't match this, then it's automatically going to print this. So we'll print the answer for you. Okay. And the nice thing about working with doubles is you'll get the decimal answer for that division. Does that make sense to everybody? Okay. So it's not used that often because, again, a lot of times you don't want to go back early, but it's a way to get back to where it was called from without executing the rest of the statements in the function. And so sometimes you'll see it in a void function, but not often, but you can use it if you want to. It's kind of like a break out of the function. Okay. All right. Now, this is what I was talking about before. You need to have returns on a function that's not void because it's expecting you to return something. So on the void ones, you just put return. You don't return a value. Okay. But when your function is supposed to return something, you need to return a value. So this particular function that C++ has, power of, POW stands for power of, it takes 2 to the power of 10, and it returns the answer back in place of this, and then that will get saved into X. So if your function is returning something, then when you're calling it, you should be doing something to use it. So you should either be printing it, you should be saving in a variable for later, putting it into an equation. But if you're putting this, like if you were to put this on a line by itself and eliminate the X equals, and it just said this right here, it would come back and it would float off into space because it's not being used, right? I always tell students it's like typing up your paper and then turning your computer off. It's like you didn't save it, you didn't print it, so you didn't use it, right? You have to save it, print it, do something with it, send it to somebody, because if you don't, if you type it up or if you type a calculation on the calculator and then you hit the off button, you still don't know the answer, right? You still don't have it saved. So you either have to save it for later, or you have to print it, just like when you write your paper, you have to print it. If you print it, you have a copy of it. If you, well, you have it printed, and then if you save it, you'll have it for later. You could print it or do whatever you want. But if you just put it on a line by itself, it'll let you do that, but it won't do anything. Like you'll never know what the answer is. Okay. So here's an example of a function that you could write. And so this doesn't say void. You'll never say void and a data type because that's contradictory. They cancel each other out. So you can't say that something doesn't return and then say what type it returns. And you can only have one data type that you're returning. Like you can't say int comma double like for the return type because your function can only have one function, one purpose. Okay, and that purpose is to calculate sum in this case. And then if you wanted to do subtraction, you'd have to have a separate function for that. And if you wanted to do division, a separate one. You can't do addition, subtraction, multiplication, division, and return all four answers at once unless you have some other way to save it, like an array, or unless you're doing something else. But If you're just returning like an integer or double, you can't return multiple answers, if that makes sense. So you would have separate functions for each function that you're trying to do. Okay, so this one's sum, and this is the data coming back, and this is the data going in. Think like parameters is the data going into the method. What data do you need to be able to complete the task you're asking it to do? So in order to sum, I need to have two numbers, right? Okay, now those numbers could be integers, they could be doubles, it's really up to you. But here we chose to use int. So the first number coming in will get saved in this variable, and the second number coming in will get saved in this variable, okay? So then you can add them two together, and you can return the result, okay? Now, this data type should match whatever you're doing here, and I don't know why this is a double, because that doesn't match, right? So we need to fix that, actually. So another thing I want to show you is that that should match. So we can do int result, and then we can add them together, and then we can return it. And then wherever you call this function, like whenever you say sum, and then parentheses, and you pass like 4,2, it will take 4 into this one, 2 into this one, add them together, and return 6. And that 6 will go back to where you called it from. And you can keep reusing this. You do not have to, just to show you, you do not have to create a variable. First of all, you don't have to create a variable on its own line, because that kind of takes up extra room. You can if you want to. You could condense it like that. And secondly, you really don't have to create a variable and then say return that variable. You can if you want to, if you like to do that, if you like that structure, that's fine. But what you can do is you could just put return and then put the equation, because all that C++ is doing is pulling the value from this variable. It's not actually sending back the variable. It's just pulling the value that's in that variable and sending it back. So technically what you could do is you could just do this if you're okay with it. And that would be the same thing. But you need to have a return. As soon as you have a data type here that's not void, you need to have return, or C++ will say missing return statement. And so you need to have a way to return a value, because it's saying this saying you're returning, so you need to have this saying you're returning. Does that make sense to everybody? And you can leave it the way it was before, or you can kind of simplify it. But if I want to, again, I can put it back like this, or I can do the shorthand. And that's what this is saying here, is that's the shorthand way to do it. But I wanted to fix that side anyways, because it said double. Now, in C++, the nice thing is if you have a double, it will chop it to an int. But I didn't like how we were using ints, and all of a sudden we made it a double inside there, because it didn't really make sense to do that. Okay. So data coming in that's needed to do the equation, data going out. Okay, so we call this the return, and these the parameters. Over here in parentheses are parameters. Think parentheses, parameters, P and P, right? Parentheses, parameters. Okay. Okay, so when you're looking at this, the sum function is after the main. So you have to put the prototype at the top. Remember, the prototype is the same as the header for the function, except it doesn't have the variable names. So if you look here, you can see that this has the variable names, but the prototype doesn't. And this is the same thing we're looking at on the slides, except this is the condensed version of it. It's nice to have comments that say what your function does, but that's optional, right? And then back here, you can see that we have two values. The first value is 20, the second value is 40, okay? And we are going to call the sum function and pass in the 20 and pass in the 40. Now, it really doesn't matter what order it goes in, because they're being added together. But 20 is going in number 1 and 40 is going in number 2. It's going to add them together, and it's going to return the 60. When it returns 60, it goes into this variable called total. Total was declared up here, so we're good to go. And then it's going to print the answers for us. Now, you could have put this right here, the sum function call, right in place of where you have total here. And then you wouldn't need to have a total variable if you didn't want to. So the benefit of saving in a variable is if you're going to use it multiple times after that. But if you're only going to use it one time, like you're only going to print the answer, technically you can just call the function right from the printout, and you don't have to create a variable and then print the variable unless you want to. If it's easier for you to follow that way, because sometimes CL statements can get overwhelming, then it might be easier to put in a variable than print the variable, or you can just call it right from there. That makes sense, everybody? So this can be taken without the total equals and the semicolon and put right in place of total. Okay. All right, so this is just showing you what's going on. This is actual call right here. This is the call. This name, sum has to match this name down here. If the capitalization or the spelling is different, it won't know what you're talking about. So always check, if it's not working, always check the spelling and capitalization, make sure they're the same. Try to start your functions with a lowercase letter. That's the common practice. It will still work if you start with a capital, but try to start with lowercase. And then you need to have parameters. The parameters need to have a data type. So they're both integers and you need to rewrite int for both of them, separated by a comma. Then here, you don't say the data types of the variables here because, and that's common for students to want to do that, but they have to be declared earlier because they have to have values and everything. They can't be declared in here because that's the point at which it's just pulling the values from there and sending it to the other one. So it needs to have actual values, which means it already needs to be declared, already needs to have a value. You're not like declaring it in there because it has to already know what it is. Like that already has to exist. Now, those don't have to be variables. Those could be numbers. Like technically I could have just put 20 right here and 40 right here. But the reason for like, you know, using variables is because eventually we probably want to do like user input and ask the user for, you know, those two values and then use those variables that they typed in because we want that data to change. We don't always want it to be 20 and 40. And so I know they didn't do that in here, but that's the goal, is to ask for user input. So is everybody following so far? Once this executes, it's going to return, so it's going to add the two together and it's going to return the answer back to here. And that's why it's important to have this here or to put this in a printout and a CL statement, because if you don't and you just put this on a line by itself, then you don't ever know the answer because it floats off and you don't have it. So it's important to have it. Okay. Now, this is an example of how you don't have to put it in a variable right away. You can, you know, have it in an equation, or you can put it in a printout. You don't have to see this example. You just put it straight into a variable. This one is being multiplied times something else. And so pi is a constant you have in your program, assuming that you have it in your program. And so it'll multiply that 3.14 constant that you have times whatever this comes back with. And so whatever you pass in for the radius, that's going to go into number. Now it's saying here that that's 10. So 10 will go into this, and then it'll multiply 10 times 10. It'll return 100. Where will it return it? It will return it back to where you called it from. So 100 will go here, and that will get multiplied times pi, and then it'll get saved. And so the point of this is to show you that you can put function calls inside of an equation. So they can be in an equation, they can be in a printout, they can be just put in a variable by itself. They can be put inside of another function call, but that makes it a little overwhelming. But you can put this whole thing inside another call to a function that passes that answer. Okay, and we'll do that eventually, but that's a little bit much for now. So let's break down this function. The name of the function is called square. Okay, and this is the parameter. Number is the parameter, and the data type is double. It always has to have the data type for the parameter, because you're saying what variable you're going to use in here. Make sure that the variable you're using in here matches what you have here, the same spelling and capitalization. Okay, and then this is the return type. And so I'm taking in a number, I'm multiplying it times itself, and I'm returning a double of that. Now, I know that the number we're sending in is an integer, but you can pass in decimal numbers if you want, and I'll return the decimal. Okay, so everybody following so far? Okay, good. So you always have to have the data type. You know, what is it? It can be an int, it can be a double, it can be a float. I know we don't use that much. It can be a Boolean, it can be a string. So any of the data types we talked about, it can return those. And so we'll talk about the different types. But when it returns, we need to think about what we're doing. Are we putting it in a variable? Are we putting it in a CL statement? Are we using it in another equation? What are we doing with it? Because we need to do something with it. Okay, so just as I was saying before, functions can return any of the data types we talked about. So one of the data types we talked about was Boolean. And so if you're having it make a decision in your function, then maybe it returns the result of that decision. And so maybe it's asking if a number is even or odd, and maybe the name of your function is even. And so if it's even, it'll return true. If it's not, it'll return false. And so we will have bool is the data type, and then we'll have the if statement that determines whether it's true or false and returns that. Okay, so here's an example of that even odd I was just talking about. And so the function's on the next page. So I just flipped to the next one. And so if you look, it returns a Boolean. So Boolean is actually abbreviated bool. It takes in, so I wanted to tell you, like, this parameter isn't the same data type as the return type, and that's okay. They don't have to be the same. Sometimes they are, and sometimes they're not. It just depends on what you're trying to do. So the purpose of this function is to take in a number. So the number is going to be an integer. And what you're going to do in here is determine if that is even. And if it's even, we're going to return true. Okay? So we're taking in a number. And the purpose is to say true or false. So we have this variable called bool, or that's a bool that's status, the name of the variable status. And we're going to do this logic. Hopefully you remember this. If you divide by 2 and the remainder equals 0, so remember the modulus means remainder. So if you divide a number by 2 and there's no remainder, that means that it's even. And so we'll set the status at true. Otherwise, we'll set the status at false. And we'll say return status. And so I want to show you something.
I think that in the checkpoint.
You were probably really close. I knew you were working on that. I can't remember what you had, but I know you were working.
I said if number exactly like
Modulus equal 0. There's 2 zeros.
oh, because I put exclamation point because you know that's something like not true.
Not true. Exclamation point equals. Did you put exclamation point equals? Okay.
I did try it once, and then it also set up. So maybe I should put 0 next time.
You could try and see. I can't remember exactly what you had. Sorry. It's probably, it could just be something small, like one a missing equals, or could be anything.
Sure.
Sometimes you have the right idea though, but it can be something very frustrating, right?
Yeah.
So if you look at this, I just want to kind of condense this a bit. So we're gonna leave the header the same. Now it's up to you if you want to put this curly brace on the next line. I'm just kind of doing this to show you because they have it done this way. I want to show you a condensed version. This curly brace can also go on the same line. Sometimes you'll see people do that. But you always want to indent your code inside your function so you can tell, hey, this belongs to the function, just like we do in main, because main is a function. So we could, I want to show you something. One of the problems with doing it this way, we'll talk about. But this is another option you might be thinking about. And so instead of creating a variable called status, you could just say return true. And then else, return false, which is a little more condensed, right? So that's an option, but I will mention a problem with this. One problem with this, and one reason why they write it like this, is because if you were to make this like an else if, which you probably wouldn't do, but let's say you made that as an else if and you put the condition in there that's the opposite of that one, which means that it'll give you true or false. But if C++ doesn't think that you have like a default option like an else, and it all your returns are in your conditionals, then it will get upset and it'll say missing return statement, even though you have 2 return statements. So, and it works right now with an else, because C++ says, I have to match either the if or the else. But what I'm saying is, if you happen to write like a switch, or you happen to write an if-else structure that doesn't have an else in it, then C++ will complain because it will say you don't have a return statement. Because what it's saying is, you don't have a default return statement. Like if I get all the way to the end and I didn't match one of those conditions, I don't know what to return. And so you have to either put, like, if you're going to do that, this is why people tend to stay away from that. You have to either put the default, like on a switch, put the default one, or you have to put an else, or you have to put a return outside of the conditional at the end to get away with it. But that's why sometimes people write it the way you have in the slides, because it's a little more secure. that if someone changes it, that it won't fail, because then you won't be missing a return statement. Like if you create a variable and you return at the end, see how this one returns at the end? Then that's outside of your conditionals. And so it's guaranteed to have something to return. Whereas this is not guaranteed, because if you happen to change this else to an else if, then it won't work. Does that make sense, everybody? But that does work, as long as you're aware that you do need to have an else on there that returns, or you do need to put an extra return outside of all of this. Okay, now another way you can do it that's completely fine, but might be too confusing for some people, is you might be thinking like, what if I just did this? And this is completely fine. It would, instead of saying if, what if we just did return? Because what'll happen is that has to have a semicolon at the end then. This will return true if this is true. And if it's not true, it'll return false. And so when you're talking about true or false, if it's the opposite of true, it'll automatically return false. And so if you're asking it, that's, even though it's not saying like if, it evaluates that and it either comes back with true or false. And so if that's too confusing though, then I think the if else logic makes more sense to a lot of people when you're first starting off, but you will see people abbreviate it like that. Does that make sense to everybody? So if that's okay, you can also do the shortcut version. Some people like the question mark, like where you do the, you know, if else with the question mark and you use the colon. If you like that, you can do that shortcut. So any of those ways is fine. Now that we're getting like so many different things we're doing, you'll see people write their program in so many different ways, and doesn't mean that one way is right and the other way is wrong. Sometimes one person's code might take a little bit longer as far as like how many lines of code, and that's okay, because I just want you to pick the way that logically makes sense for you. And so if it takes you 5 lines, but it takes someone else 1 line, that's okay, because I really just need it to make sense. And so if you need to take more lines, that's okay. Okay. So we have these different types of variables. And so whenever a variable is defined in a function, it's called local to that function. And we talked about this a little bit. I talked about if you put a variable, if you define a variable in a loop, it's local to the loop. If you define a variable in an if statement, it's local to the if statement. Basically, think about this. Whenever you define or declare, same thing, a variable, like you say it's an int or you say it's a double, it's only good inside the curly braces that you did that inside of. And so if that happens to be a loop, it's only good in that loop. And if it happens to be an if statement, only good in the if statement. If those curly braces happen to be a function at the top of the function, it's good for the whole function, right? Because once you declare it, from then on in those curly braces, you have it, right? But that's why you have to be careful you don't put it in an inner set of curly braces, because that's only good in that set. But that's the thing with having these functions. If you declare a variable, it's only good in that function. And then anything in like a loop header or a function header, that same thing only works in those curly braces. Okay, so you can define or declare a variable as global, meaning you put it at the top of your code outside of all the functions, and then it works the whole way through all of your code. But I don't want you to just do this to make it work so you never have to pass a variable, because there's going to come a point where not everything is in the same file, and it has to be in the same file for that to work. And once you move it to another file, that won't work anymore. And so in this class, since we're keeping things in the same file, it'll work. But when you get to like the next class, having things, just putting everything as global and not knowing how to pass from function to function is going to cause you problems, because when you move it to another file, it's not going to work anymore. Like it's only good in this file, not in another one. So eventually we have to get away from that. So it's good to know how to pass the variables. But there is some times where you want to make things global, and we'll talk about when that is, but usually you don't want to make everything global all the time. Okay, so we were just talking about this idea of like having local variables. And so because the variables are local to their function, you can have a variable with the same name in this function and the same name in this function. And that's very confusing sometimes for people, because it's like, which one am I using, right? Well, when you're in the function, you'll use the one from that one, and when you're in the other function, you'll use the one from that one. So this example has a variable called num, right? And this is the main function. And then this function has a variable called num, and this is another function down here, okay? So the num, when you're in this function, is this one, and this one, it's this one, okay? So in here, it says in main, num is 1, because we're still in main, right? Then when you call another function, and you come down here, Num is like a separate variable in a different memory location, and it's 20. And so when you say in another function num is 20, it's like you have a num here and you have a num here because they're separate. So in this one, when you're printing it, it's 20. But when I come back, like when I'm finished with this function and I come back here, I say back in main, num is back to 1 because now we're back in the main. Okay? So whenever you switch functions, it'll be whatever it is in that particular function because it's in that location, right? Does that make sense? All with me? Now, if that's confusing to you, just try not to give them the same name. Like if you, because then you can think like, oh, this, I thought that was this number, but if you're in a different function, then it will have different values. Okay. So we were talking about this. This is what the program outlook looks like. So when you're in main, it's 1. Then you go here, it's 20. Then back in main, it's 1 again. Okay. We talked about this, and I really just like to show you an example. So sometimes you want to have a global variable, but you don't want to make everything global. So normally when you make globals, they'll be constants. Okay. And so here's an example. So if you feel like you're going to have a couple different functions in your program that are going to use these values, then you can create constants. Remember, you put the CONST for constant. That means not going to change. And so you can change it up here, but you can't change it anywhere else in your program. So see how these variables are declared outside of your main. They're not declared in main. They're up at the top. So you put them up after your preprocessors. Okay. And so you set values here. Make sure you set values for them. And you write them in all capital letters because they're constants. And that means I have access to pay rate, base hours, and OT multiplier, and any function I use in this file. Okay. And so if I go over here and I have these different functions that I'm using, it knows what they are. Okay. So I can use them in different calculations. Does that make sense to everybody? Okay. Now, this one's a little more difficult, but hopefully not too bad. So let me just show you something, because I think that's going to be the easiest way to define static. Okay, so let me show you what happens when we have this function called show local. So show local has this variable called local num, which is 5. So when you say local num is 5, it prints, it's going to print that, and then it's going to set local num at 99. But what happens is after it sets it at 99, it comes back to here, and then it calls it again, right? But when it calls it again, it gets reset back at 5 again. And then it prints local num as 5. So the 99 didn't stay, right? Because it gets reset. So every time it leaves the function, a variable that's non-static loses its value. Okay. And so if you wanted to stay, like if you were trying to count something, you can have a static variable. And so see how this one is static? Okay. Because it's static, here we have a loop that goes from 0 to 4. So really goes 5 times, but because it starts at 0, it goes to 4. So it's a little tricky. We'll have to get used to that in the next chapter anyway, so it's probably good that they did that. But it goes from 0 to 4. So 0, 1, 2, 3, 4, which is really 5 times. And what's going to happen is going to call this show static method each time, or function, sorry. And it doesn't have any curly braces, but it automatically includes this line. And so it's going to call that function. This function is not going to return anything. It's just going to make sure we have a static variable here. It prints it, and then it adds 1 to it. So the first time through, it's going to start at 0, and then it's going to print that, and then it's going to add 1. And then when it leaves the function and it calls it again, it'll keep the previous value that it had for the function. And so the next time through, it'll be 1, and then it'll increment, and it'll be 2, and it'll be 3. If that variable was not static, like if you didn't put the word static there, then it would not retain, and it would just keep getting reset back at 0. So each time it would just say stat num is 0, stat num is 0, stat num is 0, because each time it leaves the function, it loses its value and it gets reset. And if you don't give it a value, it automatically defaults to 0. So static means retain value. And so sometimes, especially if you're counting things, it's good to retain it. And sometimes you want it to reset. So you just have to decide what you're looking for. But if it keeps resetting and you don't want it to, then you have to put the word static on there. And then that'll make it retain it from last time the function was called. Does that make sense to everybody? So that's what static means. Okay. And so everybody good with that? I think I want to do some examples with you because the next time what I want to talk about next class talks about default arguments and also about reference variables. And I think we've kind of already added on enough information that maybe we should like break it down a little bit and then go back to that because I don't like to overwhelm. So what I want to do is I want to open up my program here. So I have just a basic C++ program. And actually, I just want to show you this. I think I have it posted on Canvas. So I already have it done for you because it's a lot of typing. So I think I posted this on Canvas, and if I didn't, I will. But it's a lot of typing, so I'm not going to have you type it. So I just pasted this in, and I can give you this example if I didn't already do so. But this example we took a look at a long time ago. I'm not sure if y'all remember it. But it had a menu choice, and it wanted you to choose what type of membership you wanted, adult, child, senior, or if you wanted to quit the program. So let's kind of break this down. So we have down here this function called show menu. And remember we talked about this in the slides. We said sometimes functions are good for showing menus because all of this code can kind of be split off and we don't need to look at it if we're not really concerned with a menu. And so the spacing and everything, how we want it to look, it's void. Its only purpose is to show this. So whenever we say show menu like this, it's just going to call this function and display that menu. And so up here, it kind of, just makes your code a little easier because all you have to do is say show menu, and it's only one line of code as opposed to that big long menu that takes up a lot of space up there. So this keeps it nice and neat so we can focus on everything else. And if you care to look at that menu, then you just scroll down here and look at it. But if you don't, then you can ignore that and go past that. So separating it kind of gets it out of our way, if you want to say it like that. Because now we can just kind of say, oh, this is the menu. I'm not concerned with that. I'm going to move on. So what happens here is we have these different constants, which represent the different prices of the membership. So adult is 40, senior is 30, child is 20. Then we have the different options for the menu choices. So adult is 1, child is 2, senior is 3, and quit is 4. This is just for lining up the output. So it makes it look nice. Here's where you take in their choice. So you're showing the menu. Remember, the menu options are down here. So what you enter is down here. Enter 1 for adult, 2 for a child, 3 for senior. If you want to quit, you enter 4. So again, this kind of, just keeps it nice and short and sweet. And then this is where you take in their choice. That variable was declared up here. So you have an int variable for choice. Okay, so take in their choice. Now, here is just going to make sure that it's a valid choice. So while the choice is less than adult or the choice is greater than quit, which is 4. So this is 1 and this is 4. So if you enter like a 0 or you enter a 5, this is going to execute and have you enter again. So we can't enter something outside of the 1 to 4 range, is basically. So you can also word it as the choice is between 1 to 4 and then put a not in front of it, if that makes more sense to you. But basically this is saying the opposite of between 1 to 4. So outside of that range, outside the 1 to 4 range. Does this code make sense to everybody? What this is doing right here? Just making sure that our choice is valid. Okay, we're not worried about this right now. We're going to come back to that. So then this is saying if the choice is not equal to 4, which is quit. Remember, this means does not equal. So why do we care about that? Well, because quit, we don't want to do all of this, right? So if you choose quit, we'll come down here and we'll see. This is all part of if it's not quit from here to here, because we don't want to deal with it if it is quit, because quit means we don't want to do anything, right? So if it's not quit, we're going to ask them how many months, okay? And we're going to take that, and we already have this variable saved up here, okay? Months. And then we're going to do a switch that if it's adult, which is 4, then we will call this method called show, or I keep saying method, sorry. Java is method and C++ is function. Show fees function, I wish they would just call them the same thing. But show fees function, it's going to pass an adult. Adult is the price, 40. And then months is how many months you entered here. And so you have these different options. So child, remember that's up here. So here's the price for all three of those. So this is going to determine the price and then how many months. And it's going to call the function with that different option. And so down here, you have a function called show fees. And the purpose of this is to take in the member rate, which again is going to be 40, 30, or 20, how many months, and then print out the total charges. Now, the total charges are going to be the member rate times how many months, and it's going to print that. Okay? It's not going to send anything back because it's just printing the answer there. You could send back the answer and have it print up here, but here we're just printing it. Okay? So it's going to print that. Now, the purpose of this, I told you we were going to ignore that do while here. The purpose of this do while is here's the opening. So it matches with this. So it's going to do all of this code from here, line 30, down to line 63, while the choice does not equal quit. Because if it does equal quit, then we want to quit and we do not want to do it again. So if you do enter 4, that's how you're going to stop that loop. If you never enter 4, then you're not going to stop the loop. Okay? Now, if you keep entering 1, 2, or 3, you're going to keep getting answers. If you enter something outside the 1, 2, 3, then it's going to tell you you're invalid. Otherwise, if you enter 4, then it's going to stop. Does that make sense, everybody? So this program didn't have a loop before because this was way back before we did loops. So let's go ahead and run it. So here again, the choices are 1 through 4. Now, if I choose something outside that range, it's going to tell me to do it again. If I choose like 0, that's not an option. So it's going to tell me to do it again. And I'll have to keep doing it again until I get it right. Now, if I choose quit, then it's going to stop. Okay, it's not going to print any data because that means I don't want to do anything, right? So that's good. But if I choose one of the options, we already know that the invalid's not working. So let's try an option. So let's try number 1 for 6 months. And it's going to go ahead and take the price for number 1, which was 40, times the 6, and you get 240. And then I get to go again. So I get to keep going until I tell it to quit. And so I can keep picking options. So I can test all 3 of my options with different numbers, and it should give me different answers for each of them. Wait a minute. That was ironic, right? I just happened to pick the same like answer 3 times, just randomly, right? I was just kind of picking numbers. I wasn't thinking of that they all added up to 240. That's very random. Okay. I did not mean to do that. I was just trying to choose different numbers. But the fact that they all came out to 240 was kind of scaring me that wasn't working. So if you're getting the same answer each time, then there might be a problem. But I just made sure that I actually thought about what I was choosing instead of just randomly choosing number. What's the chances, right? Automatically choose something that equals 240 each time, 3 times. Okay. Does that make sense, everybody? That work? Okay, so again, the purpose of this, and you could be saying like, I really didn't need to have this menu separated. You're right, you don't. But it kind of keeps it nice, and because just think, I mean, this code could have just been put in place up here of where you have show menu, and it would have worked the same. But it kind of condenses your code, makes it easier to look at, because now, again, it takes away all that code from here, so you can really focus on the functionality of it. So what, where's your loop, and what are your conditions that you're doing? Now, I know you're probably saying like, this isn't that much code. Why can't that just be put in place? Like, why can't this just be put here and here and here? It could, but again, it's a lot to kind of look at. And if you're reusing it over and over again, it's kind of nice to break it out so that you just have this one line instead of having, I know it's only 2 lines, but it looks a little overwhelming because it has your equations and everything. So it's kind of nice to separate it. So it's not necessary, but it's nice to start learning how to break out our code because eventually it will become necessary when we get a little more complicated. But for now, I know that a lot of times it's not necessary. Okay, so what I want to do is I want to write a program with you because I know I just kind of gave you this one. So let's write one together. So let's go ahead and get Online GDB or C++ shell open if you don't already have it open. And just start with a basic template. And so we're going to start with I'm going to erase all my code. Return 0. Okay. All right. So what we're going to do is we're going to do that Celsius program that we did back when we did a loop. Okay, we did the converting Celsius to Fahrenheit. So we'll go ahead and say, I thought I was typing over here. Convert. Okay, and we want to convert Fahrenheit to Celsius. I can spell it right. Okay. And you can go ahead and put your name and today's date. Okay, now we're going to kind of go step by step through this because I'm not going to do the function yet. Okay, and I'm not even worried about like how it looks as far as the table goes or anything like that. Because we can always add that later. That's just to make it look pretty. You can, once you get the functionality, you can go back and format the table. So what I'm going to do is I'm going to worry about my for loop because we talked about this before. We want to have a for loop. So we're going to say for, and we want to go through all of the Fahrenheit temperatures from 0 to 20, including 0. So we did this back when we were doing loops. So hopefully this is familiar. We're going to say f equals 0 as long as f is less than or equal to 20. So including 20. So start at 0 and include 20. We'll do f plus plus. Okay. So f stands for Fahrenheit, by the way. Okay. So we're starting our Fahrenheit at 0. We're going to 20, including 20, and we're counting by 1. So that's going to go 0, 1, 2, 3, 4, all the way to 20. Okay. And what I want to do is I just want to print out the Fahrenheit value, and then I want to print out the Celsius value. So I'm going to have a C out statement that's going to print the Fahrenheit, but I'm going to actually say Fahrenheit here. Okay. And then I'm going to print the Fahrenheit equivalent, which would be F. Okay. And I'm going to put a space here so there's a space. And then I'm going to do the Celsius version of that. Now, here's the thing. We're going to just put the equation in here for now, and then we're going to move it to a separate function. Okay. So technically, I could just do the equation right here. I could do 5.0 divided by 9. You could do 5.0 divided by 9.0 if you want. Do this in parentheses times F minus 32. Now, the thing is, I probably should put, I'm going to do and L here. I probably should put Celsius here because I did not do that. Oops, if I can spell it correctly. Okay, and then put a space. And then I probably also want to put this, well, no, I'm going to leave it. Let's put a space here. I'm going to worry about spacing and everything later. Let's see if this looks okay for just getting the data. So we're going to run it. I'm going to see if we get some data. So it doesn't look the prettiest because there's, you know, could add some more spaces here. You could probably put, if you wanted to, instead of a space here, you could probably put a /T for tab. So remember /T means tab, and that might be a little easier. Or you could just hit spacebar a couple times. So yeah, that looks a little bit better. Does that make sense to everybody? Did you get 0 through 20 and all the Celsius temperatures? Now, I know we did this the other day, so you're probably wondering why we're doing it again. Well, it's good review loops, but what I wanted to do is I wanted to break this out into a separate equation, and you're probably saying, but it's so easy in there. I want to show you how to break it out so you know how to. Let's say that I'm reusing that over and over again. I know that I'm not, but let's say that I am, and I want to have it for later. So I need to decide, I can put my new function after main, or I can put it before. One of the benefits of putting it before is I don't have to create a prototype, but it's probably good practice for you to learn how to do a prototype. So I'm going to go ahead and put it after. But just know that if you did put it before, you would not have to do this. So when you're doing a prototype, or when you're doing a function header, let's go ahead and do that, and then we'll worry about the prototype. We are going to have to say what return type we want for the function first. And so I have to decide if I want to print in this function or I want to send back the answer. Now, because I really need the answer here, I don't want it to be printed down here. I just want it to send back the answer. So I'm going to say double here because it's going to return a decimal. as a result of that equation. So I'm really asking it for it to do this equation and send me back the answer. So I'm going to say double, and then I have to give my function a name. So I can call it convert to Celsius. Oh, I cannot spell that. Keep messing the S. Okay. And then in parentheses, I have to tell it what information I need in order to convert to Celsius. So I would need to have a Fahrenheit value in order to convert to Celsius, right? So I'm going to make that Fahrenheit variable a double. And then I'm going to hit curly brace and hit enter. So you should actually have two curly braces. If it didn't do that for you automatically, make sure you have a starting curly brace and an ending one. So this is our parameter here. And then all we're going to do is we're going to take this equation here and we're going to move it down inside here. Now, we have to do a little bit more with it. So first of all, I have to put a semicolon at the end. But this won't return the answer. So I can either create a variable to save it into, or I can just put return. So I can put like double A equals or double C equals and then say return C or return A. Or I can just say return and return the answer. Usually that's a little easier, but if it's easier to create a variable, then return that value from the variable. That's fine too. So this is the data coming in. It'll be used in this equation. Make sure that the name you have here and the name you use here are the same. Now, I know you have F up here, and that's good because actually, I'm going to show you how that works. Yes. So no, you can just say return and put the equation, but if you want to create a variable, you can. You would probably call it C for Celsius. So I would put something like C equals return C. So F is what's coming in, C is what's going out. Or you can just put return. You don't have to create a variable for it. You could just put return here and you don't have to like put it in a variable, then return it. Because all it wants is the value. So it doesn't matter if the value comes from a variable or the value just comes from the equation by itself. As long as it's not too confusing to put return there, you could just put return there. Okay. And then what you're gonna do is up here we have a problem, right? Because we need to put the call to down here. And so the way to call it is you have to put whatever name you came up with down here. So if you want to copy that, you have to put the name. It has to match exactly. So make sure the capitalization, that's one bad thing about making really long names, is you're likely to misspell or miscapitalize. But if you just call it convert, that's confusing to people because that would mean convert what, right? And if you call it Celsius, that might not be enough to tell that we're converting to Celsius, like Celsius what? Are we figuring out the Celsius, or are we taking in the Celsius? What are we doing with Celsius? So I think that's pretty obvious, but okay. So in here, you need to have parentheses and you need to pass in what value you want to transfer from here to here. This I purposely did, but it might be tricky, so I want to talk about. So the call to the function is the same name as what the function is, right? And then what value you want to pass in should be something that's in this function here that we can use. So the thing that's changing in the loop that we want to use is that F variable here. So that's what I want to pass in. Each time it will be different. The first time F will be 0, and then F will be 1, then 2, then 3, right? So the first time it'll pass in 0 to F here, and it'll calculate it. Now, you might say, how can I have an F here and an F here? How can they have the same name? Well, this function is separate from this main that has F. And so this F here in this loop in this function is different from the F here. We talked about that before. If you don't like them having the same name, you can definitely change it. Like you can call this one FAH, except you would have to change your equation to make sure they have the same name. So whatever you're using here, you would have to use here in your equation. But if you don't like them having the same name, then you can definitely change it. And again, I'm going to simplify this so we don't have so many variables. It's completely fine if you like it that way, but sometimes it's too many variables. Okay, so then what it's going to do is it's going to take in the value 0, transfer it to here, calculate it, send it back, and it's going to print it here. And then the next time this loop increments, it'll become 1, 1 will get sent here. It'll get calculated, sent back here, printed. 2, send 2 here, calculate it, send it back here. So it should still work the same way. The only thing that C++ is going to get upset with me for is right now this function is after the main and I haven't created a prototype. So it probably will say something about that. Okay, probably tell you it doesn't know what that is. Okay, so it doesn't know what that is because when it got to this function, you didn't tell it about it yet because it's after main. So the function either needs to be moved before main, which would be fine, or you need to create a prototype for it. Okay, so what I mean by that is either take this code and move it up here, but when you're moving it, make sure you don't leave off a curly brace. Move it before main, and that'll cause it to work, so I'll show you. Try that. That's one way to get it to work, because I never do this way, so let me just make sure you know. If you just put it before main, oh, maybe I really do have a problem. Oh, did I miss the?
You missed the.
I
You have an extra.
I have an extra. Yeah, thanks. Thank you. Okay. So here's my table again. And then you're probably saying, I did this before. Why did I separate all that? I know. But we're just trying to learn how to separate. So that was one way to solve the problem. Another way is you can, again, leave it down there. Just make sure you don't mess up your curly braces. Okay. And then you can put your prototype at the top. So your prototype can just go right before main, and it would be the same thing. You can copy the header from here, and then just get rid of the variable name. That's all it is the same thing without the variable name. Okay. Does that make sense? Let's make sure that works because I moved it back down here. How did that work? I still get my table. And again, I know you're probably saying that seems like a lot of work, and I had the table when I just had the equation in here. And that's the part I'm trying to say is like everything that we do this week and next week, not all of it seems useful because you're again probably saying I could have done this without using a function, and I know that. Just like in the last program, you could have put the menu right in your main. And I know although it looks a little more overwhelming, it was a lot easier than splitting it to a separate function and then calling that function. But the idea is that we're just trying to do these stepping stones to learn how to do it. And then the goal is that eventually we will need to do it. Like eventually we would push to do it because there won't be any way to do the more advanced code that we're trying to do without doing that. And so we have to like take these small stepping stones while the equations are nice and easy to get there. And then eventually you'll need to, like in the second class, you'll be in Java. And there's no way to do this object-oriented things that we're doing without having like these separate functions. Okay. But right now, again, I know it seems like that just seemed easier when the equation was up there and not all that extra because you don't have to learn about like the method return types or parameters or anything like that or prototypes. And I know it's kind of like, why? And I used to think that way when I first started too, but eventually it all kind of comes together as you get more and more code. Then you start understanding like, I really need to break this down. I can't have everything in main. And I know we don't reuse a lot of things in the past, but as you get more and more code that is actually more meaningful than calculating Fahrenheit, you will find a need to reuse it. And also a lot of times when you're working on projects, a lot of like programming projects, you're not the only one working on it. And so like those huge video games that you do, you might have a small piece, like your job is to program the sword, right? And then there's so many people working together that you need to be able to modularize things so that you can separate and it can all come together and all tie in. You can't just have one massive program all in the same place. Yes.
I was in Game Lab in UTD this semester, and you would not have been able to make a game like we did without it because version control requires that you check out a file. And if you check out main to adjust anything, no one else would be able to work on it.
Yeah, exactly. Thank you. Yeah, you can't just leave everything. I know it seems easier, but you can't just leave everything in main because in main is not where you want to have all your code, right? Yeah, because like you're saying, like with version control is a great way to make sure that you can work together and know what people changed and what they're working on. But if everything's just in the same place, you really can't do it. You have to be able to split. But I know that like looking at this, you're like, that seems like useless. So yeah. Yeah, I mean, you can split all of your equations into separate, then you can reuse that anytime you want. Like, again, I know you can reuse it by copying the equation and pasting it, like, that's, but just think like, and I know we don't do this, but like this, if you made a mistake and let's say you copied it 10 times, the likelihood that you're gonna mess up one of them, but if you know that you only have it once, you can change whatever changes you want to make, like, let's say you did 5 divided by 9 instead of 5.0, and you did it 10 places in your program, now you have to go change all 10. But the nice thing is that it links to this, like, it's like, oh, use this, now let's change it in one place so that it updates everywhere. So think like if you really did have a massive program that used an equation, and you just went to that equation, changed it one time, everywhere you use that equation would change. You wouldn't have to go looking for that equation throughout your program, because that'd be a headache, because if you forget one place, then it doesn't work. And it's like, if you have this game that's using this calculation and you're like, where did I put that calculation again? It's like, no, it doesn't matter because you can put the prototype and then you can put it wherever you want and it can be, yeah. And you can reuse it. So yeah, it's great because then you have this one place that people can go to change it, and everything that is relying on that can change accordingly, like from that one place. And so it's just like your central like place to go. And so you're not like going looking for like, oh, I need to, where did I put that again? You know, and it can make things more condensed too. So when you're looking at the code, it logically can break it down. So I'm only focused on like the loop because I don't have all this extra garbage in there that I'm not worried about, like this with this menu, right? The menu is kind of like plunking up the code because now I can focus on anything else. So it kind of gets it out of the way too. So yeah. And you could tell it's some person, you're in charge of the menu and then write your own function for that. And you're in charge of this, write your own function and then like bring your functions together in the program to work. And then we can all use them. So, okay, so, with that, we'll stop this.